we apply a 2-volt battery to a capacitor and then remove the battery without disturbing the charge on the capacitor. The plate spacing is 0.001 meters, and we can ignore fringing fields. And the energy stored on the capacitor is 1 joule. So let's look at the initial condition of our capacitor. So we start with 2 volts dropped across our capacitor, so the electric field intensity is 2,000 volts per meter. We have some initial charge on the capacitor plate, so the initial electric flux density field is that charge density on the plate, which is the charge on the plate divided by the plate area. Initially, there's 1 joule of energy stored on the capacitor, and we have an energy density of 1/2 the permittivity, it's free space, so that's just epsilon sub 0, times the initial electric field intensity squared. A dielectric with dielectric constant of 2 is now going to be slid between the plates to completely fill the volume between the plates, and we're not going to disturb the charge on the plates. So now we're going to find what has happened to the electric field in the capacitor, the voltage drop across the plates, and the energy stored in the capacitor. So the charge on the plates have not changed, and that's the only free charge in our structure. So the electric flux density field will be the same after we put in the dielectric as it was before. And we know that the initial electric flux density field is equal to the permittivity of free space times our initial electric field intensity, and our final electric flux density field is equal to the permittivity between the plates, which is now 2 epsilon sub 0 times the electric field intensity between the plates. So the final electric field intensity is half the initial electric field intensity, so it's 1,000 volts per meter. So integrating the electric field intensity across our capacitor with the dielectric in it, we find that the voltage drop has reduced to 1 volt, half the initial voltage, because the electric field intensity with the dielectric is half the initial electric field intensity. So our energy density now is 1/2 our permittivity, which is now 2 epsilon sub 0, times the electric field intensity squared, and our final electric field intensity is half the initial electric field intensity. So rewriting our final energy density like this, we see that the final energy density is half the initial energy density. Since the volume of the capacitor has not changed, that means there's half the energy in the capacitor after inserting the dielectric, so there's 1/2 joules of energy now stored on our capacitor. So where did this energy go? As the dielectric starts entering into the capacitor, it starts to polarize, and so there will be an attraction between the charges on the plate, the free charges on the plates, and the bound charges forming on the surface of the dielectric. So the capacitor exerts a force on the dielectric, pulling it in, and so potential energy that was on the capacitor goes into the mechanical work of pulling the dielectric in between the plates.